review.
Right.
All right. So the nice part is that the first question, at least, is a just a function. Well, actually, the first 3 questions are stuff that we've done before in calculus.
Yeah.
Doesn't necessarily mean they remember how to do it very well, but should look.
What do you want to focus on first? Do you want to?
I don't know. I kind of just want to go through the review problem by problem, work it
Okay.
out together.
Just you have more limited time than I do right now, so I just want to make sure you get what you want.
Yeah. I figure that I'll walk through with as much as I can with you guys, and then walk through with the tutor.
Gotcha.
All right. So starting with y equals, we're just finding the derivative.
Mm-hmm.
Oh,
It's just the 2 product rules, basically.
yeah.
Now here's the hard part, the algebra, though. I always mess up on something.
All right. So if I remember correctly, the product rule is simply just the derivative of one times the other
Mm-hmm.
plus the derivative of the other times the one. So
Yep, that's right.
and then it's just like you said, the algebra, factoring everything out.
Mm-hmm. Although right now I can't remember how to do the sine to the power.
Yeah, I was just about to ask you.
I can't even think where to begin.
I think you have to bring it 6 out in front, and then
I remember doing what is it? If you square cosine or sine, you can split it off into 1/2 plus cosine double angle, but I don't remember doing anything with 6s.
yeah, and to the negative fifth.
Alrighty, so what are you guys working on?
We're starting with problem 1 and working our way down.
Problem 1 on the
Review.
Don't we have a quiz today, or are you talking about the quiz review from Tuesday?
We don't have a quiz this week as a group or individually that I
No.
found. He said instead of doing a quiz this week, we're supposed to go over the review for test 1, which he has under the due Thursday box. If you see differently, let me know.
Do Thursday, lesson 6, lesson 7, group meeting, group quiz.
In the group
self-report.
meeting, it says that there's a quiz due, but if you look in my math lab, there's no quiz, and in the review section, he says, "Do this instead."
Oh, so we don't go self-report quiz or anything.
We have to do the self-report quiz.
Oh,
I mean, all that is saying, "Hey, we met as a group. Here's the link to the video."
oh, okay. And then, okay, so what do I need to pull up to be on the same page as you guys?
Just pull up the review, the student version. Okay, so this. Yeah, so I think the way it works is that the 6 does come down, and so it becomes sine to the 5th, and then it multiplies by
X.
derivative of sine.
The derivative of it. Oh.
And we would get into the derivative of the inside of sine.
So we'd get 6 sine to the 5th x, and then it would be times the derivative of x, which would be 1. Is that what you're saying?
It would end up being, I think it would be, you got the x squared, but then times 6 cosine x sine to the 5th x times 1. But,
Right, yeah, okay, I think that's what I was saying. I think, anyway.
so you take down the number and basically one version. Okay. I think I
So then for the cosine derivative, it would be -5 cosine of -6. Power -6. Right?
Yes.
Okay.
Yes, I believe so.
Wow, this is crazy. Okay.
Well, it's actually not that gross thinking about it. I definitely remember doing worse in calculus.
Yeah.
Okay, you're talking about number 1a,
Yeah.
x squared sine 6x plus x cosine -5.
Yeah, we were trying to remember what to do when you got to the power of.
Okay. Yeah. Let's see, what do we do? You gotta take it by parts. Let's see.
Basically, you just take it down and make it 6 derivative of sine, or derivative of the trig function. Or, yeah, I know what I'm trying to say.
Oh, okay. So it becomes, for sine it goes to cosine, for cosine it goes to negative sine.
Yeah, so for the first part, it would end up becoming
2x.
6x squared cosine x sine to the 5th x. I'm pretty sure.
The x squared wouldn't change to 2x.
No, because because of the product rule, you have to start with the. I already did the first part of the equation where I got 2x sine to the 6x. Because with the product rule, you take the derivative times the non-derivative of the second part plus the
Derivative of the
non-derivative
first and not of the second.
Yeah.
And that's what you did for both sides of the plus sign.
Yep.
Oh, okay. So the final answer should be 2x sine 6x, then x squared sine cosine x.
6x squared cosine x sine to the 5th x.
Oh, okay. Yeah, I did it backwards. 6x squared cosine x plus.
And I took the derivative and got 5x sine x
sine x
cosine to the negative 6x plus cosine to the negative 5th x. think that's right. You guys get the same thing? Ready to move on, or?
Yeah, I think so. I'm just simplifying it and probably don't. I was just seeing if there's something else I could do, but it doesn't look like it really.
Yeah, I don't think there's a real good way of simplifying it. Honestly, even if there was, I'm not sure I'd want to take the time if it's not obvious, you know?
Right.
Because the more steps you add to the math problem, the more likely you are to make a mistake.
Yep, that's true.
Hmm.
All right, so we're all good for that. So it's 2x sine to the 6th power x plus 6x squared sine to the 5th x plus x times
You forgot a
cosine.
cosine x there.
What's that?
You forgot a cosine x in that second part.
Oh my heck! Thanks. Yeah, I don't even know what I did. I wasn't thinking there.
Yeah, because that's part of taking the derivative of bringing the 6 down.
Yep. I just skipped that for some reason. I got everything else. I think I got all the numbers right. Okay. All right. Well, now I'm on the same page.
I've never been good with the natural log ones.
Yeah, same here.
So I think the first thing that we do with the natural log ones, take the 7 out. Don't have to worry about it.
Right.
And then we have to take the derivative of the inside. No.
Oh, you just used the chain rule on this one.
Yeah. Yeah, like the f of g or whatever.
Yeah, f prime of g of x. So it's the 7 ln. You take that, and then you multiply that by the derivative of the parentheses, g of x or whatever. And now I don't remember logs.
It's 1 over. It becomes 1 over
Is
log.
that the 1 over x?
Yeah,
Yeah, that's right.
1 over log of x.
Yeah.
So it's not too bad, actually.
Okay.
Or does it become 1 over x?
It does become 1 over x, I believe.
Okay.
So I've got 7 times the natural log of 6 natural log of x. And that's
Wait, why do you have natural log of 6?
Isn't that? Oh, what? There's no logs. No wonder. Gosh.
So
Okay.
log
Let
equals
me redo that. I was
log.
integrating and I didn't mean to.
Let's see, the derivative of
So it should
ln
be
is
6 ln of x under for the first derivative. And then it should be 6x. Is it 6 over x or? I think that's what it is.
No, you take this. You can take the 6 out.
Right, when you do the derivative, so.
Kind of like how you do this. Take the
The first
7
one.
out.
Right. So it should be 40. Let's see, that should be 7 anyway. Okay, so that should be 7 over x ln
Oh,
x.
got it. I figured out what I was
Yeah.
doing.
7
Okay.
Okay.
7 over x ln x.
Because we end up with 7 times 1 over 6 ln x times the derivative of 6 ln x.
Yeah.
You take the derivative of 6 ln x, which is just 6
6
times
over x.
1 over x. The 6's cancel,
Right.
and so it ends up being 7 over x ln x. That's what I got.
Yep. That's what I got eventually.
Yep. That's what I got.
Moving on.
Yep.
All right. This
See?
one won't be too bad.
I'll say it. It'll be horrible if you say it like that.
Nah, I think it's just a combination of A and B.
That's
So
true.
that's actually pretty nice, I think. So I get 6 over cosine theta. I think.
Just 1 second. I get 6 sine theta over cosine theta. How about you guys?
I got 6 over sine of theta. That would be negative, right?
Actually, you're right. It's negative. -6 sine theta over cosine theta for me.
Yep.
So the way that I got that is I took the natural log, the derivative of the natural log, which became 1 over 7 cosine 6x times derivative of 7 cosine 6x, which take out the 7's get rid of each other. The derivative of cosine 6x is 6 cosine 5x times sine x, or negative sine x. And then cosine 5x and cosine 6x, you can cross out some fractional stuff there. And then I get left with -6 sine x cosine x.
Let's see.
I think I did something screwy there. Give me 1 sec. Let me go over that. Okay, so it's going to be 1 over
It's going to be 1
7
over something. 1 over
cosine
the
6 theta, and that's going to be multiplied by 7 times a negative 6 sine to the 5th theta, correct?
No. Negative sine x, or sine theta, times cosine to the 5th theta.
Why is that? Because it's just the sine we're taking, or cosine we're taking the derivative of.
Yeah. So you're taking the derivative of cosine 6 6 theta, and the way that you do that, like we did in the first problem, is you take, so it becomes 6 times cosine to the 5th theta using the power rule times the derivative of cosine theta, which is negative sine theta. So it becomes negative 6 sine theta times cosine to the 5th theta.
I guess I'm gonna have to go over that. I thought I had it figured out on A, but that doesn't make sense in C for me, or B, whatever it is.
I think that's a C.
Okay.
Well, let's check the solutions first before we go way off.
Yeah, I haven't looked at that yet.
Negative 6 tan theta. Is sine theta over cosine theta tan theta?
So it's sine over cosine.
Okay, so my answer is correct.
Okay, so I just
So I took the ln and I did 1 over the 7 cosine 6 theta.
Yep.
And then taking derivative of the 7 cosine 6 theta is negative 42. The sine's negative times the cosine. So I put the negative out in front and did negative 42 cosine to the 5th theta sine theta.
Yep.
And then
it's just fraction reducing since from there.
Fraction reducing, and then once you get here, your trig identity changes from the sine on top and the cosine on bottom, makes it a negative 6 tangent.
Yeah. I left mine sine cosine, but whatever.
Yeah, either way.
Oh, okay, I see now. It's just confusing a little bit.
Yeah. It's not easy to see at first.
No.
The starting point is always the hardest for me.
Yep.
I think that I'm glad that we went over these derivatives actually, because I was not sure about the trig functions when it came to derivatives.
Mm-hmm.
I'm glad we went over that. All right, moving on. Number 2.
Number 2.
Linearization. I've always sucked at these, to be honest.
Yeah, same here. I don't know what to do with my notes. I just know basically it's y equals mx plus b is what you're trying to do at this point, or lx if you're doing parameters.
Well, the change from let's see.
So we know the slope is going to be 6, right?
Yeah.
Yeah.
Okay.
Interesting.
Gosh, I'm just trying to think.
How much will f change from 4 to 3.9? Well, so if it's 4 and it's 3, it will be the slope times 4, which is 44, and then minus 21, and that equals 3. I don't know. 4 times.
So for a formula for linearization, I have Lx equals f of a plus f prime of a times x minus a. So it looks like 4 is going to be our a. So then f of a, 4, that's going to be 3 plus 6 times x minus 4. So I get 6x minus 21. That's if the formula I pulled out was right. My initial guess was close-ish. Well, except for the b coordinate wasn't right, but it's definitely 6x is the slope.
Yeah. So where did you get the other part from?
So I took notes, I think it was during the first week, over the linearization part, and that formula is L of x equals f of a plus f prime of a times x minus a. And so f of a, or in this case f of 4, is going to equal 3. So I put 3 plus f prime of a, which is going to be 6.
Uh-huh.
And 6 is going to be multiplied by x minus a, which in this case is 4, because that's what we input.
Yep.
And then distributed it and solved and consolidated it.
And it's 21
Minus 21.
minus 21. Yeah, that's what I got in my head. 6 times 4 is 24. Then you got to get it down to 3. Subtract 3 from 24 is 21.
Yeah.
Well, that is the linearization, yes.
Okay.
Y
So
equals
how much will it change when it's 3?
21. Oh, that's logical. Never mind. That's obvious. Okay. I understand how to do that now.
Yeah, the only thing that I didn't really understand was getting the b, unless I looked at this formula.
So
However, where is the estimate coming from?
so now we change 4 to 3.9 and we subtract those two numbers. So our equation is y equals 6x minus 21. We plug in a 4 and we get 3. We plug in the 3.9 and we get, let's see, I gotta use calculator. 3.9 times 6 minus 21 equals 2.4. So our number goes from 3 to 2.4, which is an estimated difference, or the estimated change of 0.6.
I think your answer technically answers the question better than the answer he has in here because he just put 2.4.
Oh, okay.
I think that you're answering it correctly, though.
Sweet. It's the change is 0.6 because his answer is the 3.9. Turns out to be 2.4.
Yeah. But that doesn't actually answer the question anyway.
Yes. Maybe it answers B, or maybe not. Give the linearization. Okay, so the
No,
linearization.
that's the y equals 6x minus 21.
Oh, okay. Well, then we're done.
Yeah.
That's easy.
And the second part is the exact same as the first. So do you guys want to go over it real quick or
That wasn't too hard.
no? Once you remember the right equation, right?
And you understand that the derivative is the slope, then it's easy.
I feel like that's most of math, as long as you remember certain principles.
Just know the background of it. All right. Number 3.
Yeah.
Estimate how much change will 3 to 2.9. Okay. Same thing.
So this one we're gonna have to do a few times until we get it to repeat. Okay, let's see. Okay, sine.
My answer for A is 0.4.
Oh, you get down to number 4. Okay.
No. For question 3.
Question.
Oh, wait.
Oh, I thought we
Oh,
were on
my bad.
question
I was at part 2. I didn't see that. Question 2, part 2 is what I was doing.
Oh,
Which one are you on?
well, I thought we said 3, so that's where I jumped off to.
My
Yeah.
bad. I didn't mean to jump, but
No, you're fine.
all right.
I don't know. So how do you find the part B on those of 1 and 2? Because I guess I wasn't paying attention.
Okay, for question 2, part B.
You just take the derivative of that. That's all you do, right?
So I took for f prime 3 equals
Mhm.
4. That means the slope is 4. So then you do y equals 4x, and so then you plug in your 4x and you plug in 3 into x. You get 4 times 3 is 12, and you know that for the function of f with 3 plugged in, it should be 2. So you got to get that answer to be from 12 to 2. So you subtract 10 and you get 2. So it's 4x minus 10.
Oh,
I don't know if I said that really fast because I don't.
no, I got it now. I just wasn't thinking how to do that at all.
I could do.
But
There's a
that makes
couple.
more sense.
There's a things. Let's see. We could do a screen share and I could show my screen and write it down.
Sure, if you want. Then I can double check I'm doing that one right.
Let's see. Yeah. I have an online class where we have to draw on. We have to do an online video call and write stuff down. So I just have to download this PDF and then I can pull it up.
Gotcha.
Okay. This one's review. Set one. Okay, here we go. Let's see if I can do this. Screen share. How about that? Can you see my screen?
Yeah, I can see it now.
Okay. I don't have really good handwriting, but so we have f prime with 3 in it. So we know we're gonna get y equals something x, and then probably a plus or minus something. And so we know f prime with 3 put in is 4. So I just put a 4 here automatically.
Mm-hmm.
And then let's see, so the regular function of f with 3 in it is going to be 4 times 3, which is 12. But we need the answer to get to 2. So to get to 2, we minus 10 from it, and we get 2. So here we put our minus 10, and that will be our function right here. Yeah, and
Yeah,
then
that makes sense seeing it out like that. Just I couldn't remember how to connect the parts together that way.
yeah, and then when we want to find the estimated change, you just plug in 2.9 goes into there, and then you get 1.6 is I think what it was, and then you just subtract 1.6 from 2, and that gives you 0.4 as the change.
All right.
Yep. Yeah, so this is telling you the slope, and then you plug in 3 for 4 times x, and then it gives you 12 down to 2. Yeah, I don't know. It's the best way I can explain it.
All right. I think I got her figured out.
Okay. All right, so are you good, Donovan?
Yeah, I had that down.
Okay.
Right now, I'm just trying to remember my integration rules.
Yeah. Okay, so yeah, integration by parts. Yeah, this is where I will need your help probably.
I suck at this stuff.
All right.
I'm looking at my cheat sheet of basic integration formulas right now.
I think on this one it doesn't matter which one you really integrate or uh, take the derivative of, because I think it basically just is cyclical. So we're going to get it back to that equation on top. I think if we integrate cosine, yeah, I'm trying to remember how to do that with the 3 in there. Well, maybe it's easier to. I don't know.
You have to
I think
do it by parts.
yeah, exactly. I guess I'm going to put my u is equal to e to the 4x, because that way it's just going to produce 4e to the 4x every time. So it means dv is going to be cosine 3x. So that should be sine.
Yes, I know I have a tutoring appointment in 15 minutes. Thank you.
Hmm.
Hmm.
Oh, that's why. Okay. That's where I was forgetting.
What's that?
I was trying to remember how to even begin, and I remember I found the formula finally. The f of g prime equals f of g minus f prime g. So we start with f equaling either cosine 3x or either way. F of g.
So which one are you guys choosing for you?
I put e to the 4x.
Okay. That's the one I'm going to go with then. So then du, you get 4e to the 4x. The next integration for that, 16e to the 4x. Next one's 64 e to the 4x. Can't remember how many we need to go through, just a few. I don't think we need to go too far.
You only integrate it one time, I believe. So I agree that the 4 goes out in front of the e to the 4x.
Okay. It says, I was looking online because I couldn't remember where to find it, but it says the integral of cosine, like 3x, would equal 1 over 3 times sine of 3x.
Because the integral of cosine is sine.
Mm-hmm. So if we do the same thing and we take the integral of the sine, we should get a negative 1 over 9 sine 3x. Oh, I mean cosine, sorry.
Hmm. Huh. I don't know. I'm gonna go to the tutoring center later today, and I'll review this question. I'm not really sure. The
Yeah,
4,
it seems a little more involved than what I was planning on.
It's
yeah,
very involved.
Yeah.
you're gonna get some crazy stuff out of it.
Yeah, it doesn't look. His answer is e to the 4x times 4 cosine of 3x plus 3 sine of 3x all over 25 plus c.
Wait, what was the beginning part?
um, just for the answer is e to the 4x times, this is all in parentheses, 4 cosine of 3x plus 3 sine of 3x, and in parentheses, all over 25 plus c.
Oh, okay. I don't know where the 25 comes from, though.
I haven't gotten that far.
I can see where the 4 comes from, and then the 3, and the cosine and the sine, but I don't
Yeah,
see.
that 25 doesn't make sense to me either.
I don't know why 25 comes out. Because 3 times 4 can't go to that.
Well, there's not even a 5 anywhere to be found. Well, maybe I don't know. I haven't even done my terms yet. I've just done derivatives and integrals.
I got it to this point, but then I'm confused now how to add it all together. I have e to the 4x cosine 3x over 4 plus 3 e to the 4x sine 3x over 16 plus 9 e to the 4x cosine 3x over 16. I don't know where to. I'm assuming that I just added it all together, but I don't know how that would equal 25.
Yeah, I don't know, man. It's just getting confusing.
I don't know. Okay.
Yeah, that's okay. We can move on. I'll go to the tutoring center and ask.
Yeah, I'm going to the tutoring center in about 5 minutes. I need to get going in a couple.
Oh yeah, you have a meeting. Let's see, how many questions do we have? Ooh, there's 11.
Questions.
Wow. Want to just do one on 4? Oh wait, do you have to go right now?
Probably should, I guess.
All right.
I don't know.
That's okay.
All right. Well, I guess I'll stop this video and then send you guys the link so that we could turn in our.
Sounds good.
We met as a group.
Yeah.
Yeah, I'll just have to do the rest of it later. That's a big review.
Only 11 questions.
I know, but each question takes forever to answer.
And the test is going to be even more.
Yeah. He says about 2 hours though. I don't
2
know.
hours for the test?
I think so.
I've never spent that long in the testing center. I'm going to have trouble.
Wow.
Mm-hmm.
Taking longer than an hour on a test gives me severe anxiety.
I think it does that for everybody.
Yeah.
All right. Well, I will talk with you guys. Should we meet next Tuesday for our group meeting?
Sounds good to me.
Yeah. Yep, Tuesday sounds good.
All right. See you guys next Tuesday at 10 then.
All right. See ya. Thanks.
Yep.